so it's been quite a time. So from episode 6, so we'll get going with episode 7. Oh, I just want to know you that I missed an episode because I couldn't find anything about it. So we're gonna skip that one. But I mean, actually, you guys probably will understand it. And this is the thing, and this is going to be, and this lesson is going to be a very important lesson, sort of like a checkpoint, which I'll talk about in a minute. So before we're going to review the amino acids, these are the side chains. That's the alanine base, the side chains. There's the hydrocarbons, the sulfur side chains, the oxygens and nitrogens in the side chain, the negatively charged side chains, and there's the positively charged and the aromatic. Aromaticity we're going to talk about in later episodes, like in DNA and RNA and nucleotides. But aromaticity we'll talk about later, but aromaticity is what makes these different side chains. Okay, so before we skip on, I just want you guys to review and definitely actually just take a screenshot of this page because it's just really important. So that's it. And amino acid dry activity. If you can snowball fight. This is actually kind of very freezing because it's winter right now. And well, draw 2 amino acids on a sheet of paper. Like for example, one person will draw alanine and aspartate. And then crumple the sheet of paper and have a snowball fight. They throw it around. Each person collects one of the snowballs and find a pattern. Discuss what the problem could determine, and here's the collection to draw mistakes and corrections on the board. So this is a good idea. If you're just doing like a single one, you can do it with like your parents or your family or your friends, and then it's a good one. We're going to talk about peptide bonds. Today's peptide, right? Peptide bond. So how do you form a peptide bond? Remember to do the activity. Peptide bond. Okay, how come this is? Oh yeah. So firstly, you pop one oxygen off your alanine. So you probably have some alanines or any other amino acid lying around. And firstly, get this oxygen, we zap the band and pop it off. Then you're gonna need these 2 hydrogens with the bonds and pop it off the nitrogen, the H3 plus. The next thing is you're gonna form a water. And then you can connect it, and that's a peptide bond. Just nitrogen and this hydrogen is the peptide bond. Actually, the hydrogen isn't really important, but this nitrogen is the peptide bond. So we're gonna do that one more time. So you can see we have the O minus H3 plus. You're gonna pop this O minus off, and then this H3 plus off. These 2 hydrogens with the bonds off. Then you're gonna form a water, and then what happens is that these will form a peptide bond. This nitrogen is the peptide bond. Same, see? And this forms, you can see the drawing here. You can see OA, the water is being released. Concepts and vocabulary. This is the peptide bond, remember. Okay, now, when you draw these, I want you to do the thing that we need to talk about in a minute. It's very important. It's called chirality, which we probably talked about in the last episode. But notice that to join stream and 2 other molecules are produced. That's what I like to do. And amino connects, they create a polymer called a peptide. We've done polymers before in episode 4 where we did plastics. Remember, it's the same, but it's called a peptide. Oh, by the way, if it's above 2, if 2 is called a dipeptide, above 2 is called a peptide, and above 50 is a polypeptide, and above 100 is a protein. Peptides just make a protein, which we'll talk about in episode 11. The formation of other thing is known as dehydration reaction. We're going to see dehydration reactions like when we polymerize DNA and do carbohydrates. There are dehydration reactions. That means water is being released because you're sort of dehydrated. Okay. It hasn't residues because they haven't distilled, they haven't dried up. So we're going to call these residues. Very important. We're gonna do the. You can see it pops off, and then that's it, and then you can see. Okay, so I'm just gonna skip all this stuff. And then this. Remember that both amino acids that make the peptides are left-handed. This is the important thing I want you to remember. Notice that the side chains enter in and that in, out, right? Left-handed, left-handed. Because I want to connect the way that allows the sunshine to point opposite direction, when you choose the solid and dotted wedges. The dotted wedges mean that you're pointing away, and solid points us. I think we did the wedges in the flavor molecules, which I haven't talked a lot about, but this is where it gets really important in amino acids. And amino acids and peptides just like a protein, which is the main part of biochemistry. So anyway, so side chains can be point up and towards and down and away from you. This starts this skeleton structure of polyalanine peptide. Side chains are the in and out. So look, you can see this the giraffe thing. Up, down, up, down. When I was learning this, I drew it up and down, up and down. So this carbon is going to be this carbon. These two are the same carbon. They're the same thing, but they're just upside down. And this upside down is also very important in disaccharide when we get to carbohydrates. So it's kind of confusing, but do it. And then the carbohydrates, it's the same thing. So peptide building activity. Find the partner each with them. And if you're not in a classroom, if you're the student, and then you can find your family friends. Remove all atom only from one element. Remove switches, including bonds from the other element. Make water. Build peptide. Connect the amino acids. To extend the chain. Use the one-letter amino acid code to spell the name in the peptides. So. Remember that in the amino acids, I told you that each of these has a, you can see GAV, Y. Hey, there's sort of a mnemonic that I like to use for hydrocarbon side chain. It's because you notice at the end it spells lip, and then the GAV is sort of something which is the part of that, which is the carbon part of it. Okay, so where did it go? Wait, I hear it. Okay, where did it go? Here. This don't just a name in the book. You can write out other atoms or use the carbon skeleton instead. This is the carbon skeleton. I think we talked about that. Talked about that in the flavor molecules. You know how much now? Oh no, 10. So that's spelling it. That's not spelling my name, okay? You can extend it just in case, and here's the 3D model. Looks very fancy. Some grades OH are the OH, so you can see a lot of side chains. This is just an example of a person's name. Asparagine, asparagine, isoleucine. Wait, how come they're both asparaginose? Wait. Oh no, I had a mistake here. Oh my god. Because D is aspartate, or the base version. My asparaginase, oh my god, I had a mistake there. It's two different things. Oh my god, I had a mistake there. So where is it? I just had a mistake. Sorry, that was very funny. If you just noticed that, well, I haven't noticed it till when I did anyways. So that's that name. You're going to spell your name in the peptide. Then we do that. Sorry, but however, not every. I can't spell my name because my name contains an X, which is the amino acid X, and my entire family can't spell that because they all contain some. Not this one, not every name, but it's just for fun. The backbones are carved up by containing carbons and nitrogen. You'll notice there are two main parts of a peptide. You can see these, and then the side chains. There is the side chains. These side chains. The peptide ends or termini have names, sort of like when you go to an airport, they have terminus A, terminus B, etc. It's the same thing. The amino terminus, the left end of the peptide with an exposed amine group. The carboxy terminus, the right end of a peptide with an exposed carboxylate group. Remember? Okay, I might be going a bit fast, but you can pause the video to figure it out. But this is called the N terminus. This is called the C terminus, or termini for plural. That's what we call. We call just the N termini, C termini. And then the backbone, the side chains. The side chains are what makes each different. Each amino acid different. Same to a peptide. Hallmark practice certain peptide focus on peptides, bonds, and handiness. Especially the handiness in the side chains. They're very important. Peptide bonds link it Some peptides cover the flavor of fruit. Isn't that interesting? Like the beefy peptide is found in beef, and there's the umami flavor due to glutamate and aspartate. So you can see there's some glutamate and aspartate. You can see there's three of them. And one of my favorite peptides is the meaty beefy peptide, and that's actually quite a creative name, right? Meaty beefy, no. Aspartame is an artificial sweetener, 200 times sweetened than table sugar. It is soda, be good, and NutraSweet. So it's like artificial sweetener if you put it in your water, then it's because it has this little negative. Notice extra carbon carboxyterminals. That's actually something we haven't noticed. Some peptides have romance thoughts and feelings. Okay, so this actually is kind of looks very fancy because there's this SS disulfide bond, and this SS disulfide bond, which okay, I have this little guy here right now. Okay, so wait a minute, let me find it. Yeah. So here it is. This is talking about peptide. Yeah, we are talking here. Where it is? Oh yeah, here it is. So here the SS. Okay, I can't find it. That's funny. I just thought anyway. Okay, so this S is called the disulfide bond, and it's between two cysteines. You may have noticed each cysteine has an SH group, which we'll talk about later in episodes. But you can notice that the cysteine has SH, and the SH, the two H's get off and form hydrogen gas. While the cysteines go together. So this is getting awfully weird. Where is it? Oh, where is everything? Okay, here it is. Sorry for that inconvenience. Okay, what's really going on? Okay, here we go. Ah! Oh my god, this is a service. Okay, here we go. From the disulfide bond, I don't know what it is, but maybe you can find it later. Oh yeah. From the peptide bond, let's see. Oh yeah, anyway. This disulfide bond, it's got the H bond, the hydrocarbon, and the disulfide bridges, or disulfide bond cysteines. Ionic interactions as well can happen. We're going to also do ionic bridges between amino and charged amino acids, which we'll talk about the ionic bonding chapter, which is actually very important and interesting. So I really can't find it. There's supposed to be. Oh wow! I really can't find it yet. Yeah. This is the dipeptide, which you guys don't know. The R group is the side chain. But sometimes people may draw in a different way. So let's see what else have I gotten. Oh yeah. So what? Okay. So there's another way of drawing it. I'm not gonna do it right now, but there's a different way. This is called Okay, everything doesn't work today. Actually, there's a non-amino acid, but I forgot the love hormone, and the word amino acid because of including bonding between the mother and me. Other effects are such as feeling accent. It can use feelings of empathy towards other people. So let me exit full screen. So here is a pymol. Pymol, you can see that's disulfide, and we can try recognize. You can see that there's a proline right here. Proline sort of changes direction of the peptide because prolines have this weird structure. Okay, this thing is kind of messy. So wait, let me do something. And then let me activate. Okay, now it kind of looks a bit better. The sculpting scenes, which we'll talk about in the sugars lesson, but you can see it's kind of moving. So actually really slow. It's actually taking a lot of my computers. My computer's gonna go slow, but this is so it's a bit clearer now. You can see this tyrosine, and there's two cysteines, and you can try them. Oh yeah, and there's this I think of leucine or valine, something like that, and there's like an asparagine, and you can go ahead you can identify what's here. There's a lot going on here, so that's oxytocin. And okay, where did it go? Where's Crown? No. Oh no. Oh yeah, here we go. So oxytocin is a 9 amino acid peptide. Cysteine reduces can link into for creating a cyclic ring peptide. We'll study this later just so it's a bit more stable, because it's gonna be like floppy and spaghetti like on life of this and protein. Yeah. Now this is a carboxyterminal protected by an NH2 rather than an NH2 plus, and that sometimes depends how we perceive and react. So it's already been a lot of amino acids seen, and look at this. This is called a codon wheel. It codes for, because when mRNA, when our cells make mRNA gets translated into proteins. So each of these letters represent a nucleotide, which we're studying as a nucleotides episode. But this is, so for example, A, which code for lysine, serine, you can see each of these as, and there's 3 stop codons, and methionine always starts with protein. Always. It's the code for the star. So it's going to be G, and then a U, and then A. You just have to align it. This is the 5 end, the 3 end. Which we'll also talk about in the DNA. This is where it gets very genetic. This is a codon here. Or you can also do a codon chart. Okay, this is kind of unclear, but the first base, let's do C. The second base, let's do an A. And then the third, let's do a C. So it's CAC. What's that, the CAC? Well, CAC would be like something like histidine. You can see CAC is histidine. So we'll study more in the later episodes of like the genetic stuff. But is okay. Let me see why today about episode. Substance P. 11 amino acid proteins in terms of signals between neurons. As many as a biological organ is being studied for the sensation of pain, the more they reflex inflammation, mood learning, and cell growth. So before we end this, I want you to show you. Okay, this is basically the end. This is the MK1 receptor. Receptors to stuff. So you see the MK1 receptor is actually a protein. You can see these are secondary structures we'll talk about later. Actually, let's see. Let me hide all this stuff. It's just really so messy. Okay. Now this is substance P. And remember I just highlighted the MK1 receptors there. Okay, so this is actually kind of, you can see this long bond you see, it's just because our time is getting a bit weird. It's actually kind of hard to tell, but the pink is basically just the carbons. You can probably identify a few, but it's kind of hard. So it's not the way you're used to. That's another way. So let me change it. Okay, now it looks a little bit better. Now, and it's not that much. Okay, I'll get a zoom out. So there you can see there's a logo. Oh yeah, there's another, probably histidine, and you can see a cysteine right there. And then there's another carbon, I think it's a tryptophan or something. And then there's a few more amino acids there. You can go ahead and look at this. This is actually really cool. So where's the other stuff? Okay, now we need to. So okay, it might actually look kind of okay. I don't know. So that's the Okay, so this is the secondary structure. That's the receptor, and then I'm gonna show the spheres. Okay, now this is the full thing, and now I'm gonna now you can see. Okay, let me undo that. Okay, so I should ribbon. So this is getting a bit weird, but I think this is the end of it, and you can pause it for now. But you can see that all this, and that's it. So so I remember I said earlier that there's multiple ways. Okay, this is mainly that. So what was it? Okay, anyway, so okay, more view of the sensor. Okay, more now. Oh well. So I'm just gonna search for alanine. Let's just do alanine. You can see this is the cloud. This is another way. This is more view. It's free online. But however, this is let's do the cleanup thing. So some more view. Actually, I don't know what's going on. But anyway, that's it. So I will see you later for episode 8. Yeah, we'll see you later and bye.